Pluto is some separation from the Sun, of course, so the sunlight is on different occasions fainter than it is here on Earth. So, it's cold, temperatures lower to around -230 degrees Celsius during the night. In an power wave, you could get as high as 170 degrees Celsius. It has an undeniably problematic climate, excessively inviting curious brains to an examination past the unmistakable areas of our nearby planet group. Think about how possible it is that I told you that Pluto, the distant and secretive Bantam planet, is finally taking its endless development, likely crashing into, in all honesty, Neptune, the ice monster. Pluto's resistant nature has been obvious from the start, a revolt on the edges of our heavenly area. It circles boldly, experiencing another planet, challenging the normal prerequisites of planetary conduct. I mean, that is no sort of chap for a planet. Right from the puzzling intricacies of Pluto's circle to the raised worries voiced by astrophysical illuminators like Tyson and Kaku, a prepared request hangs inside the boundless harmony. Will these divine beasts partake in an accident course? Should the union of their ways spell unexpected consequences for our cherished planet Earth? Today, we set out on a bombastic excursion, loaded with vulnerability, while the responses to these divine inquiries might get away from us at the present time. The potential for an effect of such self-important volume fills in as an unmistakable update that the universe is a stage for occasions both dazzling and conceivably a bit startling. Go along with us as we dive into the mysteries that circle how we decipher Pluto and Neptune, inspecting the conceivable outcomes of a superb battle that could reshape the boundless balance of our planetary gathering. The stage is set, and the unfurling show tempts us to observe the puzzling dance of the planets. Among other potential space fiascos, the universe harbors a choice of puzzlers. Also, among them is the troublesome enigma known as the three-body issue. Yet, researchers expect other likely disturbances in the heavenly venue. Regardless of the way that a planet colliding with one more in space is exceptionally improbable, it isn't completely impossible. Gravitational cooperations, as made sense of by the three-body issue, are one of the forces that influence planetary circles. An outline of a space framework where gravitational powers produce an periodic example called orbital resonances is TRAPPIST-1, which has 7 planets the size of Earth. As time passes, these examples could debilitate planet circles, upgrading the likelihood of accidents. What goes on? Does it reject any accidents? In spite of the way that frameworks, for example, TRAPPIST-1, are very thick and planets influence each other's courses, particularly when they are close, researchers consistently monitor these frameworks to sort out this. With this data, we can more readily figure out how the planets travel through space. Another dark but acknowledged component is rebel planets, which move heedlessly in space, all things considered, of and circle around a star. Discharge of planets from star frameworks can happen due to gravitational pulls or other cosmic quirks, like another star's close approach or dynamic flimsiness in frameworks with different planets. Over time, these meandering planets can travel tremendous separates, potentially arriving at regions far from where they started. It is conceivable that they'll run into other star frameworks on their lone experience. The chance of a planet crash increases on the off chance that such a planet is going to, regardless. Another close-by planet bunch, a rebel planet striking another planet head-on, would be far-fetched. Taking into account how tremendous and for the most part vacant space is, the sparsity of planets in open space and the immensity of interstellar distances cooperate to dissuade normal crashes. It is now exceptionally far-fetched that 2 rebel planets will influence, however, the frequency of rebel planets is far lower than that of stars and planets in stable circles. The star frameworks included can become turbulent in case of an astronomical consolidation. It is exceptionally improbable that planets will influence head-on during these monstrous occasions due to the huge interstellar distances. The circles of stars and planets in arising frameworks are changed firmly by significant locales of energy for the gravitational powers. A planet could turn into a rebel planet, freed from any star when such an aggravation drives it out into the dull profundities of intergalactic space. On the other hand, planets might be launched out from their circles, collide with other divine bodies, or even impact their host stars due to these gravitational unsettling influences. When gas and residue are compacted under incredibly high tension, gravitational breakdown can in fact make new divine bodies form or potentially start stars to arise in our planetary group. The late weighty assault recommends that around a long time back, there was a time of expanded influences involving comets and space rocks. This flood in heavenly activity is accepted to have come about because of gravitational unsettling influences brought about by the external planets. During this violent stage, gas monsters like Jupiter and Saturn were going through movement, upsetting the circles of various more modest bodies in the Kuiper belt and space rock belt. Therefore, these more modest items were tossed into unconventional ways, with many progressing into the internal planetary group. This inundation drove to a huge ascent in influence on the earthly planets, including Earth. While these impacts didn't include direct crashes between planets, they delineate how gravitational collaborations can prompt critical changes in the directions of heavenly bodies. This commotion is remembered to have assumed a crucial part in shaping the surfaces and geographical records of planets in our planetary group. Besides, it would have added to the dissemination of water and natural materials to Earth, affecting the advancement of our planet over an expanded period. As stars go through changes in mass streams, then, at that point, parts of planets around them could wind up farther and, presumably, cross. This is especially critical in frameworks where stars are approaching the finish of their life cycle. As a star becomes older and consumes its atomic fuel, it frequently undergoes huge mass changes, particularly during stages like the red giant stage or on the other hand when it discharges material in a planetary cloud. These varieties in heavenly mass can fundamentally influence the gravitational equilibrium of the framework, causing the circles of adjoining planets to either move outward or become more minimized. This is bound to happen in multi-star frameworks, where complex gravitational collaborations can without much of a stretch lead to temperamental circles. In such frameworks, the gravitational powers from different stars can associate capriciously, worsening orbital interruption and increasing the possibilities of circles joining. This can result in circumstances where planets could get caught by another star, collide with other divine bodies, or even get launched into interstellar space. Pluto's remarkable circle, initially perceived as an unmistakable part of the planetary family, went through a renaming, ultimately being assigned as a Bantam planet. In light of its unique circle, the cosmology community remains captivated by it and thinks that it is intriguing. In spite of this change, there is cause to stress with respect to the closeness of Pluto's track to Neptune's. As indicated by later figures made by prestigious researchers like Neil deGrasse Tyson and Michio Kaku, these researchers are sounding the alert about a grave peril to Earth, the likelihood of an effect between the planets. Pluto is not normal for some other planet in our local planet gathering, and its orbit around the Sun is so remarkable. Pluto has not finished a full revolution since its discovery in 1930. Furthermore, its orbit runs an expanded 248 years. The way that it drifts off altogether from the normally circular orbit of the massive planets makes its way very strange, further adding to its standing. Pluto likewise has a more outrageous orbit than other planets, since its tendency to the ecliptic plane is 17 degrees, adding eccentricism to Pluto's orbital pattern. The place where Pluto's orbit runs into Neptune's is an interesting component. During around 20 years in each circle, Pluto ventures closer to the Sun than Neptune, testing suppositions in light of their particular situations in the neighborhood planetary gathering. This leads to the question, why hasn't an effect between Pluto and Neptune happened? The clarification lies in the gravitational impacts applied by different planets. The appraisal of Pluto's circle started quickly after its disclosure, giving a troublesome problem to space experts, dissimilar to most planets whose circles adjust particularly near the ecliptic plane. Pluto's exceptional qualities include a precarious tendency and a circular shape. The secret extended with the acknowledgement that Pluto's circle crossed that of Neptune. The three-body issue, Pluto's circle stays stable in the midst of the intricacies, filling in as a demonstration of the natural intricacies of heavenly mechanics. Grasping the movement and gravitational cooperations of three divine bodies, like Pluto, Neptune, and the Sun, is known as the three-body issue in space. Predicting their directions from their underlying positions and the impacts of gravity on one another is comparable for Pluto. A portion of the terms that help to settle this cosmic issue are AST libration, scope libration, and the VZK wavering, as indicated by astrophysicists. AST libration is critical in light of the fact that it keeps planets in their circles. When Pluto crosses Neptune's circle, it is something like 90 degrees far off, which is a basic distance that forestalls influences. According to this definition applied to Pluto and Neptune's degree libration, insinuating the vertical development of a divine body in its circle ensures that when Pluto approaches Neptune or other giant planets, it is situated for the most part over their orbital plane, giving an additional layer of security against crashes. A basic variable in it is to figure out divine movement. VZK wavering, named after three researchers, Van Lee and Kai, they investigated the gravitational connections between three space objects, including Pluto, Neptune, and the Sun. The VZK wavering sorts out why Pluto's circle around the Sun seems unprecedented but stays consistent over time, notwithstanding the clear abnormality in space. Stowed away examples, furthermore, rules hold everything under wraps. These factors together stabilize Pluto's circle, forestalling impacts with Neptune or deviations from its way. The three-body issue permits us to comprehend how the gravitational pulls of these space objects influence their course. Considering this improves how we might interpret Pluto, our neighborhood planetary gathering, and divine bodies. Numerical reenactments in the late 1980s uncovered that, regardless of stable properties, Pluto's circle is for sure tumultuous, with minor starting deviations, leading to huge varieties over millennia. Regardless of this inherent disorder, Pluto's circle exhibits astounding soundness over immense stretches, really moderating anticipated choppiness later. Computerized reproductions have worked on our comprehension of the mind-boggling elements, counting the effect of enormous planets like Neptune, Jupiter, and Saturn on Pluto's way across the Sun. Neptune's significant gravitational impact, finishing 3 circles for each 2 of Pluto, significantly adds to the general soundness of Pluto's orbital way. Jupiter's gravity is too huge, but less so than Saturn's. Taken together, these observations outline that Pluto is in stable and normal movement throughout space over billions of years. It is critical to consistently study and investigate these occasions. Space investigation frequently uncovers the erratic way of behaving of heavenly bodies. Pluto's circle is a work of art illustration of this capricious way of behaving. It shows how minor changes in the Bantam planet's area or speed can significantly influence its orbital course. Researchers' understanding of Pluto's development in space is to a great extent due to advanced reenactments, which impersonate the gravitational associations between Pluto and other planetary bodies like Neptune. These recreations use complex numerical models, permitting stargazers to perceive how little changes can fundamentally affect Pluto's course. The instance of Pluto gives a clear delineation of the idea of orbital mayhem, exhibiting how the direction of a divine body is exceptionally reliant on its beginning stage. For a long time, researchers' understanding of Pluto's development in space has been helped by advanced reproductions. These models have uncovered captivating experiences into the complex dynamics of the Bantam planet's circle, revealing insight into its particular conduct and highlighting the many-sided transaction of gravitational powers in our planetary group. These reproductions have, moreover, assisted researchers with understanding the potential dangers related to Pluto's circle, especially corresponding to its closeness to Neptune. While a genuine crash among Pluto and Neptune is profoundly doubtful due to gravitational impacts from different planets, progressing exploration and observing are fundamental to survey any possible dangers to Earth and our planetary system. Pluto's circle and its communications with other heavenly bodies present a captivating and complex riddle for cosmologists. In spite of its tumultuous nature, Pluto's circle stays stable over tremendous timescales, exhibiting the perplexing equilibrium of gravitational powers at play in our planetary group. Through numerical reenactments and continuous perception, researchers keep on disentangling the mysteries of Pluto's circle and its suggestions for the elements of our enormous area. Investigating the profundities of space offers a window into the wonder and motivating intricacy of the universe, where heavenly bodies like Pluto challenge our comprehension and touch off our interest. As we venture further into the universe, the privileged insights of Pluto's circle and its collaborations with adjoining planets vow to divulge new bits of knowledge into the dynamics of our nearby planet group. Furthermore, the more extensive universe beyond Pluto's circle has long interested space experts because of its one-of-a-kind qualities and its associations with other heavenly bodies, especially Neptune. Initially delegated the 10th planet in our nearby planet group upon its disclosure in 1930, Pluto was subsequently renamed as a diminutive person planet in 2006 by the International Astronomical Union. This renaming ignited re-established interest in grasping Pluto's circle and its place in the planetary group. One of the most captivating parts of Pluto's circle is its flightiness and tendency. Comparative with the ecliptic plane, not at all like the circles of the significant planets, which lie generally near the ecliptic, Pluto's circle is profoundly disposed at an angle of around 17 degrees. This tendency, joined with its circular shape, makes Pluto's circle essentially unique from those of different planets. Moreover, Pluto's circle is additionally unique in its communication with Neptune. While Neptune is the 8th planet from the Sun, its circle crosses with that of Pluto intermittently. This really intends that there are times when Pluto's circle brings it nearer to the Sun than Neptune's circle. Notwithstanding this nearby methodology, real impacts among Pluto and Neptune are exceptionally far-fetched because of the complex gravitational cooperations between the two bodies and different planets in the nearby planet group. The investigation of Pluto's circle has prompted the improvement of numerical models and reenactments to better comprehend its way of behaving. These recreations consider the gravitational impacts of the Sun, different planets, and, surprisingly, huge space rocks and Kuiper belt objects. Through these models, researchers can foresee the future direction of Pluto and evaluate any potential dangers related to its circle. Late progressions in computational methods have permitted for additional precise recreations of Pluto's circle, uncovering its innate soundness. Notwithstanding its tumultuous nature, while minor irritations can prompt critical changes over significant stretches, Pluto's circle remains astoundingly stable over billions of years. This soundness is a confirmation to the fragile equilibrium of gravitational powers that oversee the movement of divine bodies in our nearby planet group.